Welcome everyone to this session of Alpine University's webinar series. This is our December webinar, and our topic today is Visual Displays, Design Principles for Testing Programs. My name is Yana Harrison, and I'll be serving as your moderator today, and I work on the marketing team here at Alpine. We'll get started in just a couple of minutes, but I wanted to make just a couple of announcements first. If you find value in attending today's webinar, make sure you look out for your invitation for our very first webinar of the new year that will be held on January 20th, 2016 of next year. So make sure to watch your email for your invitation. If you have questions today throughout the presentation, please do use the raise your hand feature. I'll unmute you long enough for you to ask your question, and then we'll go back on mute when the exchange is complete. Also, you feel free to use the questions module on your screen. If you're having technical problems with the webinar, please, as a first measure, close down and restart the application. If that doesn't work for you, please go to gotowebinar.com for support, and they will walk you through troubleshooting measures to rejoin the webinar with us. Last but not least, we'll be covering a lot of information today, but don't worry because we're recording the presentation, so if you miss something, you can always review the presentation once it's been posted to the Alpine website, and we'll send out a download link and an email with the full link, with a download to the full recording and the full slide deck. So without further ado, our presenter today is Dr. Brett Foley, psychometrician here at Alpine. And with that, I'll turn it over to Brett. Brett?
Thanks, Yana. Welcome, everybody. I'm very happy to have you all here before your holiday break. Hopefully you have some useful information for you. There we go. The objectives of this workshop, first of all, I want to give you some examples of how to use visual data displays in the test development process. And when I say visual data displays or visual displays, I'm talking about things like graphs and tables and visual organizers, timelines, that type of thing, that sometimes when we think about those in test development, a lot of times they might get brought up during discussions about maybe producing score reports as something handy or nice to have in there. But really there's a lot of useful places we could use those throughout the test development process. So I'd like to just show you some different ways that you might not have thought of for using those types of displays, not just at the end of the test development process, but throughout. And secondly, I'm going to spend some time talking to you about design principles for effective displays. So there's a lot of guidelines out there. So this will sort of synthesize a few of the recommendations that scholars who work in this area have put together for developing effective visual displays. So we'll show you kind of where you can use them and how you can make effective visual displays. Why might we want to use them? Well, we deal with, in the test development process, a lot of technical issues, a lot of technical psychometric issues. And the folks we work with, folks like organizational administrators, subject matter experts in the content areas of the specific assessments we're developing, are test users or consumers, the folks who are going to use the test or either take the test themselves or use the test results. They might have a lot of expertise in the areas that the assessment is being developed in, and they're essential for the test development process, but they might have little or no psychometric background of their own, so that the psychometric concepts that are necessary for developing the test could be kind of beyond their everyday experience or expertise. using visual displays can be a helpful tool to help folks understand those processes. It can reduce the cognitive load if we can show somebody something through a graphic that might be easier for them to relate to than a long technical report. For example, one of the most common graphics that we use at Alpine is this one you'll see here that shows one example of a fairly typical test design process that shows the life cycle of a test design and hopefully gives the user the impression that at each of these stages that we're collecting evidence that supports the validity of the interpretations of the results, which is kind of our ultimate end goal. So graphs like this can help people understand kind of what the test development process is, and if you're doing a specific activity, where that fits into the process. I'm going to actually use this one today to sort of guide the initial part of this presentation, talking about, we'll go through each of these areas and identify, well, how could we use a visual display within each of these steps to help our subject matter experts or other folks we're working with better understand what we're doing and help them have a better idea of the overall process. So starting at the design the program stage at the very beginning, that's where we answer questions like, what's the purpose of the exam? What questions are we trying to answer by using the assessment? What's it for? Who's going to be taking this test? We might use something like something you see here, just a visual organizer, to talk about first identifying the intended purposes of the test and then identifying the types of validity evidence we could collect to support each of those purposes. So a graph like this helps people to understand that, well, we really need to clearly identify our intended purpose of the exam, and for each of those purposes we need to develop some evidence that supports those interpretations. So something like this could be helpful to help summarize that. I mentioned score reports. Score reports aren't really the focus of this presentation, but because for score reports on their own, there's many issues about, and we've had some standalone webinars on those that you can look back and identify some best practices for if you're interested. But score reports are really useful even at the very beginning of the test development cycle, before you've even given an exam. And one of the reasons why is if we mock up a score report at the very beginning of the process, that really tells us and helps us understand the type of information we want to know. If we have something like this that shows us what we want to know at the end, that can help us in the design process. That can help. You can share that with your psychometric vendor and say, this is the type of information I want to be able to share with test takers at the end, and that will give them a lot of information. So for example, in this example, we can see with the bar across the middle saying we want to take the test scores and break them into performance categories, 4 of them in this case. We can look at the table at the bottom and see, okay, we want to also not just report total scores, but we also want to be able to report sub-score areas, and then the different areas at the bottom show us that we want to be able to show some normative information as well. How well are the test takers doing with respect to their peers in a school or a state at that level, the school district or state level? I should point out the examples I'll be talking about today are drawn from a mix of areas of assessment. Some of them will come like this one, could be from K-12 education assessment, but you could easily adapt this for a credentialing exam or a licensure or certification, either in IT or a medical field, for example. So I'll try to pull from examples from each of those, the different areas where you might be working. But also try to keep in mind to mention how you might generalize these to your specific area if that's not exactly what you're working on. Timelines can be really useful in the design process. This is an example from the International Hearing Society, folks who work with helping to fit hearing aids. And this is an example that they shared with some of their members that helped them summarize the development process of their assessment. They wanted to share some information about how they assess the life cycle of the assessment, and they used this particular timeline to do so. They labeled some specific important points, and they also used some symbols to identify some recurring activities that happen multiple times. Say, you can see along the bottom the stars and bullseyes that show that throughout the development cycle, there's regular item writing and review cycles that happen throughout the process. Once we decide the test purpose, we get to the design stage of the assessment itself, where we ask questions like, what format should the test be? How will the test be administered? How many forms do we need? In this stage, deciding things like test forms. How many test forms are we going to use? And also getting a little bit more technical, what sort of equating design? How are we going to ensure that those forms are fair for everyone, that everybody's treated the same within terms of the expectations of the exam? Equating can be a challenging topic, and there's many psychometricians who spend their whole days doing equating. But it's important for our constituents to understand how the test equating process helps to ensure the equivalence of expectations across test forms. A graphic like this one, again, is just sort of a graphic organizer that makes it clear for somebody who's looking at it, saying that, okay, we're going to have for each year, we're going to have 4 test forms. And test forms are going to be linked within and across years using a set of common items, a linking set of items that are common across forms. So there's a set of items in between the 2008 and 2009 assessments that are linked together. 2009 assessments are linked to the year before and the year after. There's the first set of common items that links 2009 back to 2008, and then another set of common items that links 2009 to future test forms. When we've decided on the design of the test, we have to decide what content should appear on the exam and what knowledge, skills, and abilities should the test address. This is where we'd be looking at things like a job task analysis. Coinciding or just following the job task analysis, we're asking things about, okay, how does that content map onto our assessment? So how many test items should be devoted to each of those content areas that we identified as important? What item format is appropriate for each of those? Cognitive complexity is important as well. So the cognitive challenge of the tasks. Do we just need to remember things? Do we need to remember facts? Or do we need to bring more critical thinking skills to the process? Is that what's really important? Here's an example from the 12th grade National Assessment of Educational Progress in Economics, a recent version of it. You can clearly see here kind of the major areas that are being assessed, and then those sub areas within each of those, using this a diagram here. Blueprints, again, they don't always have to be fancy. We just have a simple table here showing how many items, and we actually have a 3-dimensional blueprint here because we have we break it down by the objective, how many items do we need for each objective, but we break that down by item type, either multiple choice or constructed response, and cognitive complexity level. So tables are useful when we need detailed level information. When we're building an assessment or building a test form, we need this level of detail. But something that you can see clearly here, so for example, what might jump out at you over on the right-hand side, that there's a lot of blank space under the constructed response. So there's only a few constructed response items on this exam, in this example. And we'll note that all 5, I should say, of the constructed response items are intended to be at the level 3. So this helps convey the idea that Okay, those constructed response items are expensive to score and an additional challenge to create, so we want to make sure we're only using those to measure really high-level cognitive complexity, those synthesis, evaluation, showing that critical understanding. So we don't want to waste those items on just remembering facts. We can do a good job with those, that type of skill, with multiple choice items. Once we've decided our blueprint, we need to create test items. So we have, in this place, you'll maybe have some item writing workshops. Again, even for something like an item writing workshop, visual displays can be helpful. So the item writers need to know what content areas to write items and how many we have and how many we need that are still remaining to be written. Here's just a simple table that summarizes those totals that we need, but we added an extra column over there on the right that uses, within those cells we show a little progress bar. So that can be handy to have kind of posted up on the screen if you're doing an in-person item writing meeting, so you can see. And then also with the addition of some exclamation point check mark icons, I should say, which areas are finished. We don't need to write any more items to that area. Or exclamation points where these are big areas of need, we really need to start working in that area. It may be a simple thing, but I know myself and our other test development professionals who worked on this, having these little progress bars and reaching the end point and you're getting a checkpoint is actually kind of something that the panelists tend to really like. It's something motivational for them. They can see their goals pretty a little bit more effectively. Once the items are written, they need to be reviewed to make sure there's no bias, they're technically accurate, they meet technical published criteria for technical quality, and we have enough of them to meet our blueprints and our program design. When we're reviewing items in education, in K-12 education, we might do an alignment study, making sure the test items match to the content standards. In credentialing, we want to make sure our items map to the correct test objectives, those knowledge skill areas. And so we're trying to convey the idea of, well, how close do those need to match? We could use a Venn diagram like this shown here, saying like we really want a complete or partial match between our items or objectives. So the objective is like a big umbrella. We want to make sure the item content fits within that broad range of content. We want to avoid those slight matches or no matches. So that can help convey that concept of the degree of alignment between the assessment and the objectives. Also, when reviewing items, we have to decide, well, when would a visual display be useful in an item? So here's an example from an IT assessment, maybe a network administrator test. On the left-hand side, it shows the variation of the item without a diagram, and the one on the right shows it with a diagram. And I won't spend a lot of time on this one, but it looks, hopefully you'll see that the item on the right makes it much clearer and much less reading and text intensive than the one on the left. And so the one on the right might be a more effective item for having a visual display. On the other side of the coin, when our items have figures and visual displays in them as part of the review process, we want to make sure they're necessary. Right? We don't want to include items that we don't want to put in a graph just because we can. We want to make sure it's necessary for answering the item. We'd like to try out our items first before we give them operationally, if it's possible, to make sure they're functioning properly. And during this stage, we have to decide, well, what sort of analyses should we perform? How big should our sample size be? Then we need to review that data that comes back. So again, this is a case where we need detailed information. We need to look item by item. So for each item, say this is an example of 10 items that came back from pilot testing on a constructed response test, for example, where each item has a possibility of 3 points. This table shows the distribution of scores, how often people get different score points, to help us get an idea of the difficulty of the item. we need this level of detail, but it's hard to get a big picture idea from the columns over on the left, the 8 columns on the left, really at a glance, what's the hardest, what's the easiest item. So we can add a couple extra columns like over on the right where we have a small little histogram showing the distribution of how often people get each score. That might help a little bit. Also, we can look at the average score on the right and the far right column, and rather than just providing summary statistics, just the statistics, we also applied a gradient on top of those. And that can be really helpful looking at long lists of numbers, doing something like applying a gradient like that. So it's obvious, it should be, hopefully it's obvious to you that, say, for example, item number 2 is the hardest, because we can see that it's by far the lightest color, and we can see that the average score on that one is 1.3, and it's easier to see that items 3, 4, and 5 are among the easiest. Everybody scores like over 3 in this case. So we'll move to the next one. Oh, and actually, I'd say that those average scores, look, that they go above 3. So that's a typo there. That should probably be a 1 through 4 scale rather than a 0 through 3. Sorry about that. As an additional part of the item review process, we might get more sophisticated analyses like differential item functioning, which helps identify items that might be biased, or at least potentially flag items that we should review to make sure they're not biased. Differential item functioning is a fairly sophisticated statistical activity, but it's an important one to do, and it's important that people understand why we're doing it. We could use a graph like this to help explain it. So in this example, we're looking at one item and how it performs for 2 different groups of people. It could be males versus females, or different racial groups, or different countries, or different native languages, or it could be different testing centers. But in this case, we can see for this particular item, if you take a person with a given ability, let's say this is on an IRT scale, but there's sort of a mid-level of ability. If they're in group B, they have a lot lower probability of getting that item right than if they're in group A. So if somebody from group B has about a 38% of getting this question right, somebody from group A has close to a 50% chance of getting this right. So this might be an item that's easier for one group than another, even when we account for that, even when we look at 2 people of the same ability. So we might want to review that item for potential bias. And we need to assemble our operational assessments after we've finished our pilot testing. But when we do that, and we have multiple forms, we want to make sure they're comparable. One way we could do that, we could use, if we're using an IRT design, we could look at the test information functions of the exams. And again, I'm flipping through some statistics here. Some of these might be familiar to you and others might not. Test information functions kind of show where is, it's just sort of how is the difficulty of the assessment spread across the range of performances. In this case, we can see there's most of the items for forms A and B, because of the difficulty of the items, is giving the most information in sort of the mid to upper ability range. So in other words, we don't have a lot of easy items on this assessment. And that's probably important for an exam like a licensure exam, where you have a fairly high ability population. So we could use these information functions to decide, okay, we want to use 2 forms this season. We have 3 to choose from during this test administration cycle. Which 2 should we pick to make sure that they're as similar as possible? Well, a graph like this makes it clear that Form A and Form B are very similar in terms of their distribution of their difficulty. Form C is similar, but you can see that there must be some more easy items on this exam, so the overall graph is shifted down a little bit. So that wouldn't be the best choice for choosing 2 out of these 3 exams, looking for equivalence. Once we give the exam, if we're placing people in performance categories or making pass-fail decisions, we need to set cut scores on the exam. We can use visual displays in the cut score process. For example, if we were setting 3 cut scores, and let's say, for example, we're using an ANGOF or a bookmark style standard setting methodology. In many cases, we use multiple rounds of ratings. So people will make an initial judgment, we'll give them some feedback, and then they'll make a follow-up judgment. As part of that feedback between rounds, often what we'll provide is some measures of, well, how spread out was the panel in terms of their recommendations? And sometimes we'd provide, say a mean or a median, and then something like a minimum and maximum or a standard deviation to help try to convey the idea of how spread out everyone is. Well, we can use a visual display, I think, in many cases more effectively than reporting a standard deviation. There's not many folks who use standard deviations on a regular basis, and so it's not really as familiar as somebody as an average would be. So a graph like this, this stacked dot plot, kind of shows for 3 different cut points on the exam, well, really how spread out are each of the panelists. So each of those dots within a row represents 1 panelist rating. So they can look at that and see where they fell compared to their colleagues in the room. This is for 3 different proficiency levels, but it could easily be for 3 different groups of panelists. So if you had 3 panels, or if you had panelists made up of different constituency groups, say for example maybe newly licensed, experienced professionals, and educators as 3 groups who are making up your standard setting panel, you could use this to look and see, well, are their recommendations consistent across that group? So it doesn't have to be for 3 different cut scores. It could be broken out by panelist characteristics. In education, and sometimes in licensure and certification, when we're setting multiple cut scores or we have exams across different levels, it's important that those are consistent or at least across those ranges. So for example, K-12, it may not be reasonable to expect big differences in performances from adjacent grades. So for example, if we're looking at the state level, we wouldn't necessarily expect a big difference in the percentage of proficient kids in grade 6 versus grade 7. So something you might see in education is something called vertical articulation, where we take cut score recommendations, which are where this solid black line would go. So saying these are that's the average panel recommendation for cut scores, and you see that kind of zigs and zags up and down. And that may not be reasonable to see that pattern. So we can put margins of error around those and try to fit a smooth line between those, or at least a smoother line that might that would still honor the recommendations of the standard setting panel, but would be more consistent across grades. So that's something you might see there as a use for visual displays. Additionally, when we once we've kind of finished our development process, our development cycle, we need to maintain the exam. And a lot of things that go into the test maintenance relate to security. We want to make sure that the test is still performing correctly over time. We want to monitor for item exposure and security breaches. So one thing you could do is use a scatter plot to plot pass rates over time. And this is something you could regularly monitor and look at your pass rate, and you could see in a graph like this, it's fairly clear that for the first 15 weeks of the assessment, the cut scores hovered around, or the pass rate hovered around 60%, but then after week 15, it shot up to around 90%. So you might want to investigate about a potential security breach at that point, or maybe recognize that you need to put out a new form of the exam because it looks like this one's exposed. We could also look at displays to identify possible cheaters, or as just presenting some evidence, additional evidence visually about potential cheaters. So we could look at test taking time versus how people did. So we could look at a graph like this and see, okay, for this exam, people who took longer tended to do better on average. But there's a small group of folks who, finished the test very quickly and scored very high. So that might be a group of folks we want to flag for additional review. Okay, so the purpose, I kind of flew through that first section, and really that's just, the point was to show you, to help get the idea across that visual displays aren't just for score reports. There's places you can apply them all through the test development process that can help your subject matter experts or the folks working in your area who don't have that technical expertise to understand more completely the processes that we're going through as part of the test development process. Next, I want to take some time to walk through, okay, how do we make sure we're using high quality visual displays? What are kind of characteristics of each of that our displays we should shoot for? And here's 6. I'm going to go through each of these 6 points individually and show you some examples. First of all, we want to make sure our display is appropriate for the data. So some of the big distinctions are tables versus graphs. Tables are really useful for presenting specific values. Say, for example, for an item analysis, we need to know item statistics for every item. That's useful when we need that significant amount of detail. Graphs are more effective if we want to see the overall trend and relationship. It's hard to look at a big table full of numbers and quickly glean sort of an overall picture of what's going on. Graphs are more effective for that and a little less effective for providing that specific detail. On the other side of the coin, we want to know when we're choosing a display, we want to make sure we're choosing the correct variables to show. So for example, say I wanted to do some analysis to see how does the time people take spending on the test, how long people take completing the exam, how does that relate to the pass rate? Well, in this example, I took some test data from a credentialing program and fit a logistic regression model. So that's what this curved line here is, just showing that using the data we have, it looks like for this long exam, the longer people take in this case, the worse they tend to do. So it looks like people who know the answers, put them down right away. The people who struggle and take a long time tend to do worse overall. But if I wanted to convince you this was a meaningful relationship, I should probably show you how well this fits the data. Well, here's the data. Here's the raw data. And we're using a computer-administered test in this example. And so we have down to maybe the millisecond how long people took to finish. And so no two people actually finished at exactly the same time. So the data isn't really that useful here for us because we have each individual person either passed or failed. So they're either 0 or 100% pass rate. So it's not really very helpful to showing us, well, did this statistical model predict the pass rate very well? Well, how could we get around that? Well, instead of it reporting raw data, we could round everybody's scores up to the nearest 5 minutes, or sorry, their time up to the nearest 5 minutes. And that would let us group people together a little bit easier. How does it look if we do that? We can see in that case, let's see, we jump to the next slide here. Yana, can you move it to the next slide for me, please?
Yes.
Okay, there we go. So you can see now, okay, it's like a little bit better of a picture. It looks like our data fits the line pretty well, except there's a few points that are way off here, that are way away from this line. So, well, it turns out that actually not every one of these time points is equally likely. Some of these data points, since we kind of grouped people by every average 5 minutes, some of them are made up based on data from many more people than others. How could we show that in the graph? Well, we could just count them up and replace the dots with numbers and say, and that gives us a real detailed information, but it makes the graph a little bit busy. So I think that maybe the best choice would be, in this case, we could say, well, let's just make the dots proportional to how many people make up each of those data points. So now we can see, well, it looks like our statistical model does a really good job with all of these big dots. Are pretty close to our line, and when we miss it, it's only in those cases where we have observations with very few people. So the point being, we want to make sure we're being thoughtful about which variables we want to show in the graph that we choose to make. Next, the next principle is that we want to aim for simplicity. Our visual display should be simple but complete. They're simple in that they don't include more information they need. They include just what they need. So graphical elements that don't convey information should either going to be minimized or removed. I'll show you some examples of that in a moment. We especially want to avoid using 3D graphs when we don't have 3D data, and in some cases, not even then. And then also we want to limit the complexity of our display in terms of fonts and symbols. I actually kind of like this graph. I think here's an example that I think it looks pretty cool. It's kind of jumping out at you. It's 3D, well, the purpose of this is to show, okay, what's the pass rates by attempt? How do people do who take the test more than once? We can see that they do better at the beginning on their first. People who take the test just one time tend to do very well. On second attempts, they do less well, and that trend continues for 3 or 4 or more exams. And then we can see that the results are similar from Form 1 to Form 2. But you might notice some problems with this graph. So for example, look at the attempt number 2 for Form 2 and try to figure out how tall is that column. And and I'll admit that I can't. I couldn't tell you how tall it is. I can't tell. Even though we have lots and lots of lines on our vertical scale and lots of numbers on here, it doesn't help because of the format of this graph. It's unnecessarily complicated. What would be a simpler version of a graph like this that can tell us exactly the same information? Well, here's a 2D version of the same graph, and it's much easier to read. Attempt number 2 for Form 2, we can see it's right in that about 50% range. We still see the same overall trend that we saw before. We still see that the forms are similar, but it's just in a more compact, easy to understand package. The next principle is that we should, when we can, try to integrate text, numbers, and figures together. I'll give you some examples of what I'm talking about here, but the principle is that information necessary for interpreting a visual display should be right there with it. We shouldn't bury our interpretations somewhere else in an interpretive guide. If we're going to present a visual display, the user should be able to have the information they need to interpret it right next to it. So labels should be close to elements they're describing, and we should annotate data when we need to. And when we do, it should be close by. So here's an example of a graph that integrates, or a table that integrates numbers and visuals. So we have the detail of a table here on the left-hand side, but then we have the overall trend over on the right with a small graph. And so that integrating a graph into a cell in a spreadsheet, the term for that, it's referred to as sparklines. Even though these aren't lines in this case, they're a little histogram, a little bar graph. The overall process of having many small graphs integrated into a table, that's sparklines. And so we integrate sort of text and visual information at the same time. Here's another example where actually we do have line graphs over here. So we might have a graph like this to show looking for items that might be exposed in terms of making sure of as part of our test maintenance process. We can see, look for items that get easier over time. So these are, there. You can see from this that there's 3 of them that do. We have the specifics over here on the left and the general trend on the right. So we're integrating text and visuals, and then we also add some additional visual cues with these up and down green and red arrows to help the user see what we're doing more effectively. Here's again another example of comparing pass rates for different groups on an exam and comparing first-time test takers versus repeat test takers. I won't spend time reading through the exam or reading through the detail here, but in this case we have a more complicated graph over on the right-hand side that includes error bars for the differences between these the first-time and repeater pass rates. And what we have at the top here is actually instructions. These are instructions for the user of how to interpret this. It's not buried somewhere else in an interpretive guide. It's right here next to the graph. Relatedly, we need to highlight what's important. We need to point the users to the areas of the graph that we want them to look at. We want to help them to come to the interpretation that we're trying to convey with the display. So to do that, we can minimize things that don't support the interpretation. For example, we don't want to use intense colors in areas that are not important. We want to reserve those intense, vivid colors for areas that need to be highlighted. So we're going to only use bright colors for areas that need to be highlighted, annotate important features, and if you want 2 things to be compared in a graph, or 2 graphs, they should be placed close together. So for example, again, here's another example that we talked about, test taking time versus test score, trying to identify potential cheaters by looking at how long people took to take the test and what score they got. Here's the data. This is the raw data here, with nothing emphasized. Here's the same data, but the graph modified just a little bit. In this case, we lightened the raw data and then increased the darkness and changed the symbol for the candidates that we wanted to highlight. Then we also added a couple guidelines that showed, well, we want to highlight people with very high scores in this case above the 95th percentile, and very low test-taking time. And then we also added a label here, so saying this is where we want you to look, and here's why. These are very high scores in a very short time. So you can see that this is an easier for somebody to understand the point of the graph than the previous one. Again, here's a graph. This is a really useful graph for security analysis, which is really a topographical map of probabilities, looking at how similar two examinees' responses are. But in this case, we have a legend over here on the right that's a long way away from the actual information where it's needed. So a more effective
version of this graph might be something like this, where elements are labeled directly rather than in a separate legend for the graph. You know, it's nice to have a legend. We want to make sure people understand what we're talking about. But if we're able to label those things directly, it can really simplify and avoid some confusion that we might have otherwise. Another principle is we don't want to mislead folks with our graphics. There was statistics, there's always a potential for misuse, and we want to make sure that we're not doing that. So we can avoid that by making sure we're not using ambiguous labels where we're very clear. Also, that we're choosing scales and aspect ratios that are defensible and appropriate. We can really manipulate how a graph looks by changing its scale. And so we need to choose the scales that make sense and are appropriate. If something is an estimate or a projection rather than raw data, that should be clearly indicated. And you should always make sure we're using appropriate units of measurement. So this is an example from a death penalty case. This is sort of a kind of a variation of a security or cheating analysis in this case, where there was somebody who was sentenced to the death penalty, and there was an allegation, there was a concern that they were trying to avoid the death penalty by faking that they had a mental disability. So this person had taken several IQ tests over time, in this case in Nebraska, where the statutory definition of mental retardation at the time was a score of 70 or less on a reliably administered IQ assessment. So here's a graph showing the 3 assessments. And it's probably okay. We have our IQ scale over here in the 3 assessments. But these assessments weren't equally spaced in time, which sort of implied by the graph here. So an alternative display that might be more appropriate is to include, rather than just categories, but actually show the time, since we're sort of implying a time series by connecting these dots. So this graph is maybe a little bit more accurate or more detailed. It's giving more information for sure. But another thing we could note is this IQ scale over here. If you were, cognitive psychology, or if you were in a field where you were very familiar with IQ scale, this could be very meaningful for you. But if you weren't familiar with it, you could interpret this graph as, oh, he went from a high IQ to a very low IQ. It may be that a more appropriate graph, a appropriate way to show that, is to change that vertical scale, because it turns out the IQ scale, if you're not familiar with it, has an average score of 100 and a standard deviation of 15. So it turns out all of this person's assessments were below average. And so if we use a kind of really closer to a full range of IQ for our vertical scale here, that gives a better picture that, and in the addition of including guidelines for what average intelligence is and mental retardation, at least the statutory definition in Nebraska at the time, that provides much more information to the user, and we don't rely on them having that understanding of what the IQ scale is. Lastly, we don't want to mislead people that we know assessments have error associated with them. And without showing some sort of measurement of uncertainty on there, we're actually risking that folks are going to overinterpret the assessments. So probably the most complete version of this graph we have here, we could add error bands around each of these scores to show that we know for each of these assessments that there's some error associated with it. So we should probably try to quantify that to help the user fully understand really how sure we are about our measurements. And we could have a whole presentation on that, just measurements of uncertainty and including those in visual displays. And I think that's a really important area to consider. Lastly, we want to make sure we pair the design with the audience. not all visual displays are going to work for everyone. We saw in that previous example, those earlier graphs might be fine if you had a really strong background in IQ scales. But it wouldn't be as appropriate if you're looking at a general audience that doesn't know what those scores mean. So it's important to work with test users and consumers. Identify who your test users and consumers are, and try out some graphs with them to see which ones work better for the group you're working with. So one way we could look at, say, average scores on an exam versus for examinees from different countries. This is a pretty plain graph, and it only gives you very limited information, so the average scores. If we had a more sophisticated audience that understood error bands, or we provided some explanatory information, we could give more information by providing the same information with some margins of error that could help understand, well, which countries are really different from each other and which ones are sort of within the margin of error that we have. Or we could reorganize the same data and use box and whisker plots and give much more data. So things like medians and averages and interquartile ranges, minimum, maximums, identifying outliers. This graph provides much more interpretive information than the first one did, but it also is more difficult to understand. So you have to consider your audience of which of these would be the most appropriate in your situation. So you really have to know your audience to make that judgment. So I want to leave a couple minutes for questions here if folks have them. But really the takeaway messages I hope you got from this, even though we went through many examples fairly quickly, I hope you, and you probably already know that psychometrics is hard, or maybe is it psychometrics are hard? I can never remember if psychometrics is plural or singular. But we can use visual displays to help make it easier for folks to understand. Hopefully I conveyed the idea to you that one size doesn't fit all. So it really, you need to kind of focus on your audience. There's lots of different ways you could present information. You need to work with the folks, your consumers of your visual displays to decide really what's going to be most appropriate for them. Hopefully we gave you some good ideas in terms of overall design principles that helps you build good quality graphs that gets you part of the way there. Hopefully you can try to be creative, and because we have lots of tools out there to make really engaging graphs. But when you can, try them out and see how they're working, and if you can, share those results with other folks. If you can use immediate different ways, let's say a webinar like this one, to share which ones have worked for you and which ones didn't, and maybe why they didn't, and what you do change the next time.
Thank you, Brett. We just want to go ahead and leave just a couple of seconds here to see if there's any questions of Brett before we close out our session. And it looks like there's no questions right now, so Brett, I'll toss it to you for your final comments, and then I'll close us out.
Great. Well, thanks again, Yana, and thanks. I want to thank everybody again for coming. If you liked any of those graphs, I should let you know that for the most part, almost all of the graphs I showed there were things that you could actually make in Excel. I think almost every, with the exception of very few, almost all of those are something you can make with. You don't need specialized software to do those sort of things. So things like sparklines and integrating text and graphics is something you can do with software you probably already have. So if you're interested to ask some questions about how we made some of those, feel free to drop me an email to ask those questions. Again, if there are any other questions, I'm happy to answer them. I have a couple of chapters you could point to if you'd like more detail about any of those specific issues. Thanks again for coming, everybody, and have a happy holidays.
And yes, I'd like to echo Brett's sentiments. Thank you all so much for coming today. We're going to follow up shortly with that download link to the full slide deck and recorded presentation from today. As a reminder, our webinar is on January 20th in the new year, 2016. And as a final thought from all of us here at Alpine, we very much appreciate your support and wish you a warm and safe holiday season and a bright and prosperous new year. Enjoy the rest of your day.